Hello and welcome to the Capri Virtual Museum. My name is Mark Brackstone and I'm a Research Project Manager at Aimsun. We used Aimsun's Mobility as a Service solution, Aimsun Ride, to test a fleet management system for a new automated pod shuttle service at Bristol Airport. The fleet management system was developed by Conigital and the testing was part of the Capri pod trials. Aimsun is a leading international provider of software and services for traffic planning, simulation, and prediction. Our team has developed a totally integrated digital mobility modeling lab. Within our software, transport planners can analyze movements at any scale, from a single intersection to an entire region. The idea is that you build a digital twin of a city or a highway, then simulate the trips that people want to make, and match them with transportation options such as taxis, buses, car shares, bikes, or even walking. Our solutions can even take it to real time to help cities with smart traffic management, air quality control, and even the latest on-demand transportation systems. Simulation is a safe and cost-effective way to experiment with different designs or operation plans and help make places safer, cleaner, and more livable. Our mobility as a service solution is called Aimsun Ride, and you can use it to test on-demand transport and city logistics applications. Ride is a bundle of standard software, specifically configured modules, and professional services that can help you develop a business case for running a service. Or you can use it to connect a fleet management algorithm to our simulator with interaction between the fleet and other road users. You can even see how your on-demand services compare with other modes of transport like walking, taxis, ride-hail operators, on-demand buses, and even traditional rail, metro bus, and tram. Of course, you'll also want to see how congestion impacts your service, model individual vehicle-to-vehicle interaction, and use aggregate representations of a transportation network and demand. You can work with travel requests based on individual agents with parameters based on anything from age, gender, eco-friendliness, or economic status. Basically, you can use Aimsun Ride to test and refine your fleet management algorithms until you get them just right. Aimsun has 9 offices worldwide, including one in London and another in Edinburgh. We work with a wide range of city councils as well as consultancies and international universities such as the University of California, Berkeley, MIT, and the EC Joint Research Centre. The UK team has led the way in our CAV research and development through involvement in a number of CCAV-funded Innovate UK projects, from Flourish through Human Drive, OmniCAV to Capri, which is what we are showcasing here today. So what has Aimsun been doing in Capri? We've been using our Aimsun Ride software to simulate the impacts of a potential pod-on-demand service at Bristol Airport, a 16-acre site in the west of England. We've been working with Conigital to investigate methods that combine Aimsun simulations with the Conoptium AI decision-making platform in order to identify optimized fleet deployments under a broad range of scenarios. In other words, we try to optimize the service by minimizing the number of pods required and their operating costs, while maximizing the benefit to passengers by reducing travel times and improving their journey time reliability. Now, Bristol Airport has an existing shuttle service that loops around the car park roughly every 10 minutes. However, this is not well utilized, so we wanted to investigate how this existing business-as-usual scenario could be improved upon with a range of alternative services. Firstly, we looked at increasing the shuttle buses to support more frequent services, 1 every 5 minutes or 1 every 3 minutes, say. Secondly, we examined 2 different modes of operation for the pods, one where the pods followed the existing bus route, and another which allowed the pods to freely route between their respective origins and destinations within the existing site network. Now, we also simulated different traffic profiles for high, medium, and low demands observed at the airport over the course of a typical day. These simulations were performed for the current year and what would be a year of 2026. In other words, when the expansion of the airport is planned to increase capacity from the current 9 million passengers per annum up to 12 million passengers per annum. In our simulation, the users of the service make a request to the operators and are then allowed to make a choice of service based on the responses the operators make to them. These services can include trips by modes such as pods, public transport, walking, and it's all based on the relative costs and benefits of offers made by the operators. Once the user has selected their preferred mode, these trips are then executed within the simulation. For a pod service, this would take the form of the user walking to a suitable pickup point, waiting for the pod to arrive, travel within the pod to the drop-off point, from which they can then get off and walk to their target destination. In order to do this, we generate a population of requests corresponding to one or more people of a group. The users each have their own characteristics and preferences and travel patterns. Some will prefer to walk, others won't. It all depends on the aspects of their travel cost that they prioritize. Now, different priorities can be defined for different user classes, which can be customized to any specific application. These services, the users make and requests for travel, which are generated during the simulation between specific locations at specific times, and they can also include constraints such as earliest and latest pickup, together with the individual's characteristics. Now, once the operating system receives the request, it examines where vehicles are, calculates the shortest path on the current network conditions, and uses the data to give the user an offer. Now, each offer may have a distinct element of walk, wait, and in-vehicle time, together with distance, service charges, and any transfer penalties that may be applicable to that route. In this video, you can see the system in action as we follow a number of pods around the car park. On the right, you can see the individual requests coming through to the system, along with dispatch and routing instructions, while at the bottom, you can see the status of the 5 vehicles that we used for this video. Here you can see the different colors indicating their status. Dark green, for example, means the vehicle is assigned to a request and is en route. Light green means the pickup is actually taking place. Dark blue means the passenger is traveling to their destination, while light blue means that the passenger is alighting at their drop-off point. The red lines indicate intervals during which the simulation of specific vehicles are idle. The combined Aimsun Ride Comoptium application performs a multi-objective optimization of the vehicle fleet, performing an intelligent analysis of the decision space represented by specific fleet deployments implemented to work under different traffic conditions and levels of service demand. Comoptium then analyzes the results from this exploration of the different implementations to try and find an optimal solution that balances a range of possible objectives, such as minimizing fleet size and idle time, while maximizing customer services by minimizing travel times and travel distances. The AI decision platform seeks to balance these conflicting demands and allow operators to identify optimum solutions that meet their service level objectives. By using simulation, this exploration can be performed with thousands of simulations, exploring the options before implementing a pod service on site. So what did we find? Firstly, user travel time on average is improved by implementing the pod service, resulting in an increased uptake of pods relative to the shuttle buses. Secondly, journey time reliability, measured in terms of variability in the average journey, is also less, so it's providing a more reliable service. And the more we optimize the fleet, the greater this improvement becomes. Obviously, there is a lot of analysis here, and if you'd like more information, please take a look at the other presentations and posters in this section. The next question you probably want to ask is, what happens when we deploy a pod service at a larger and more complex site where there are a lot more people or where pods have many more origins, destinations, and routes? That's a very good question, and as you're watching this video, we are putting the final touches to our last study within the project, which is investigating how pods could work in the Queen Elizabeth Olympic Park in London. This test site is 10 times the size of our previous investigation at 160 hectares. To investigate this, we are using an upgraded version of a static traffic model made available to us by Transport for London. We converted this to a dynamic micro simulation model with local recalibration based on traffic counts provided for the road network in the vicinity of the site. With this new model, we've been able to explore the implications of providing different free routing pod services with varying fleet sizes to see how they perform under different levels of demand. Destinations include the London Aquatic Centre, the Copper Box Arena, the London Stadium, the Velodrome, and here east. While the overall pod route is principally off-road, there are some locations where the pod interacts with traffic signalised junctions and the wider highway network, where the pods can be tested at a higher speed. Walking times from the south to the north extent of QEOP are of the order of 30 minutes, so there's the potential for pods to provide an alternative here for walking. Driving amongst human-driven vehicles only occurs in the northeast corner of the network, though one of the pod stops is on a bus route through here east. We'll be bringing you the results of this study soon, and it will be interesting to see how they compare with what we found at the airport. Obviously, once Capri finishes, there's still a lot of work to do, and we're excited by the opportunity to apply our software and services to even bigger and more challenging case studies. What happens, for example, when you have super busy areas, not just 10 pods, but 100? What happens when there are so many people that the pod can't make any headway? While it's a useful service, there will be times when it doesn't bring any actual benefit as it becomes too slow because of the traffic and other road users. If you'd like to know more about our work in this area, please do drop us an email at the address that follows, or look in on our website to see our final results and what we may do in this area next. Thank you for watching, and enjoy the rest of the Capri Virtual Museum.